Hidden in dusty barns, fields, and forests across the Americas, there is an ancient virus already millions of years old when the first humans arrived on this continent. A monster that never evolved to hunt us, remains unaware of our existence. But when it accidentally infects us, it can kill up to half of those who develop severe disease, turning the body's own emergency soldiers against the paper-thin barrier keeping the lungs from flooding. In May 2026, this ancient virus appeared aboard a cruise ship crossing the Atlantic. 13 passengers were infected, 3 were lost, and more than 650 contacts were tracked before the WHO recently declared the outbreak contained. And why this is so terrifying is that this monster does very little to turn your immune cells against your lungs. Hantaviruses live inside rodents. Each strain is tied to its preferred reservoir host. For centuries, the Andes virus and the long-tailed pygmy rice rat of southern South America made an ancient truce. The virus gained a lifelong shelter, and the rat evolved to live with it without obvious illness. But this ancient truce had a dangerous loophole. The pygmy rat sheds the virus in its urine, saliva, and droppings, and when contaminated nests dry out and are disturbed, the virus rides into the air as microscopic particles waiting to be inhaled. And with just one unlucky breath, it breaks its ancient truce with the pygmy rat and finds a new home in the endothelial cells, lining the tiniest blood vessels inside your lungs. From that moment, and without your permission, it quietly makes new copies of itself and begins loosening the molecular seams holding the barrier together. When your immune system finally detects the intruders, your lungs' resident janitors and sentries, the alveolar macrophages, are among the first to sound the alarm. They release chemical signals that awaken nearby immune soldiers and summons more reinforcements. Natural killer cells sweep in like elite security guards, carefully checking every cell for the presence of MHC1 molecules, and swiftly turns on the cell's self-destruct switch when they don't have the right ID and keeps flashing distress signals. But then they are only one of the first responders. Your cytotoxic T cells, precision hunters trained in the thymus, move into your lungs, scanning MHC1 displays for specific viral fingerprints, and if present, they dock, deliver a lethal package, and trigger the cell's self-destruct program. But because every alarm signal released summons more fighters, and every fighter releases more alarms, the fragile rescue mission becomes an inflammatory storm. You begin to drown in your own plasma because the virus silently hijacks the molecular signals needed for the endothelial cells to maintain the thin barrier. And the immune assault, now past the breaking point, keeps flooding your lungs with more immune cells. Without a licensed vaccine and no approved antiviral available, doctors can only oxygenate, ventilate, support your blood pressure, while the immune response either regains control or simply overwhelms you. The recent outbreak reinforced what researchers have known since the 1990s. Andes virus can pass from person to person, usually through close, prolonged contact with someone already showing symptoms. And as science is still devoid of answers to key questions of when patients are most infectious, or who is at a greater risk of developing the Hantavirus Pulmonary Syndrome, what this monster reveals is that the barrier between your blood and your organs is far more fragile than you imagine. After decades of research, the vaccine blueprints exist, and experimental antivirals as well as antibodies are being explored. But discoveries do not become treatments on their own. They need years of rigorous clinical trials, regulatory work, and investments to turn them into life-saving drugs. And diseases that strike unpredictably, mostly in regions with limited research and health infrastructure, are difficult to study and rarely promise a reliable commercial return. So, when the outbreak fades, the funding disappears, and promising science remains trapped in papers until the next outbreak happens and doctors are helpless, with no effective antiviral or a licensed vaccine to prevent the worst from happening.